Wow, why does this happen? Something makes Chrome really annoying to drag around in Ubuntu. As in, it like doesn't drag, or it drags really slowly. Anyway, this is gonna be a short one. What am I doing? What's the plan? The plan is, well, so today I was doing something interesting and different and fun. I decided, so since, well, I guess it's not there anymore. Oh wait, did I not just pull? Okay, so so previously there's a lot of repetition, as in it often looked like this. In fact, why have I not changed this one? Right, I know why. Yeah, previously I had a lot of repetition for my AST nodes, where I'd often have like an import AST node for this particular node. I would have two functions in it. One would be traverse, which would visit the node itself and then visit all of its child, child nodes. And then it would have an extra function called getName, which would just return a string, which is always basically the name of the class, but with node removed. So, and that was annoying. And Rust has a thing called derive macros, which is like specifically for kind of auto-generating these kind of this like impulse for a type. So I haven't applied it here because it doesn't yet work for this one, so that's currently not implemented. But like eventually, I should be able to just go derive AST node and then delete that. And I've already done it for a bunch of them though, so it does work for anywhere. It works for anywhere all of the properties of that struct. So it only works on structs at the moment. That's the thing to change. And it works with any struct where all of its some number of its fields are okay. It works on any struct where none of its fields are not like nodes themselves, optional nodes, or vectors of nodes. It works for all those cases basically. And that's because, so that's implemented up here. So I was learning how to do this. I guess I left this in. Whoops. Although maybe I want to keep that actually, so I might leave that there. So to make a derive macro, so this is a macro. And the way you do it, you have to have a separate crate, which is like a I was going to say it's like a module, but module means something different in Rust. It's like a package. And so I've got a separate package up here, a separate crate called AST node derive, and it's got a single file in it, librs, which implements the thing, and it basically takes tokens from your source code. So if I wrap, so if I put derive AST node on this, then it effectively receives a thing that's like the AST of this struct. And you can like process that AST. I can get its name. Input.ident is its name. And I can check its fields, and I can loop over the fields, etc., all that stuff. And yeah, so then it basically loops over all the fields. So I have an I have an extra thing. So when you define a derive macro, you can give it attributes, which means that, okay, let me try and find one. Here you go. So if I've got a type that derives from AST nodes, I can, if there's some fields that I don't want to traverse over, I can put this attribute skip in front of them. and it won't do it. I do actually want to include these at some point, but I've left it to do here to sort that out later. So it loops over every field in the struct, and right now, yeah, it only works in structs because this is specifically matching structs. It loops over every field. It checks if it should be considered a child node, basically meaning it's not being skipped. And if it is, then we get the type of the field, and we basically check like what is the first thing in the type of the field. Is it a vec? Then we add it to, so I have a vector that I'm filling up here, which is going to be all the children that I do want to visit or traverse over. And so if it's a vec, then I push this is the type that I've made, child field vec with an ident in it, or child field option with an ident in it, etc. So I push them. If it's a vec, I push a vec with the name of, with the identifier of that field contained within it. If the type begins with option, I push child field option with the name in it. And if it doesn't begin with either of those, I'm just going to assume it's an AST node directly. So this is going to be a bit flimsy, but it's not terribly flimsy because you'll get errors if you were to use something else. Then the magic of like doing a macro is this. Well, to be fair, this is another crate, so I don't know what this does under the hood, but there's a thing called quote, which is itself a macro, which you can give it basically something that looks like code, but you can put these like hash whatever in it. So my macro AST node gets run on the struct. So the input is effectively the struct that the macro is applied to. I'm getting its identifier, which is its name basically. And then down here, I'm injecting that name into here. Yeah, so this code isn't like actually here. Like you can basically imagine that this code ends up after the thing that is deriving from AST node with all the things substituted in. Yeah. And then the other fancy thing I'm doing in here, so like get name, I'm generating get name, and it injects new name, which I've just done. This is not ideal at the moment, but I've basically just taken the original name and then stripping out the word node, which right now could be anywhere, but I ideally wanted to just take it out at the end of the name, whatever. And then I'm also implementing traverse. Now this was interesting because it effectively has to do something different for each child depending on what kind of child it is. Is it a vector of things? Is it an optional child? Is it just directly the node itself? Those are all going to have different code. And I figured out how to do that. So you can do this. So this syntax with like, I'm just gonna put ... in it, but like, this syntax with whatever in it is effectively like a repeating injection of something. So you have to give it something that can be iterated over. So I'm going to give it children, but how does it know what code to output for each of these children? Well, I've implemented 2 tokens for child field, which basically says, so basically means that this thing has a function called 2 tokens, which takes an argument that I've got to like push tokens into. And what I do is I say, depending on the type of self, if I'm a vec, or if I'm an option, or if I'm a node, then I push into the token stream a different kind of code. So once again, we've got a quotes exclamation mark with some code inside it that I can inject into. And so this is the code for if it's a vec. We loop over, we do for whatever's in whatever, and then call traverse on it. If it's an option, we do if let sum whatever equals self dot whatever, etc. If it's just the node itself, then we just call traverse on that node directly. Okay, so that is how it works. And now I wanted to kind of finish off that process. So what thing should I do next? Because there's a bunch of things that can't have it right now. And so get value is always going to be a little bit tricky, actually. So I'll figure that out later. But there's a couple of other cases to sort out. One is arrays. Now I could just assume that if it's an array, then if it's an array, then just assume that the contents of the array are going to be nodes. I think I'm going to have to make a bunch of assumptions. So what I'm going to look up is, so one of the things I'm using is called sin. It's the thing that basically represents the AST. Okay, so at some point we have, so I think the type is not going to be path. So type, there's a type called type here for sure somewhere. Oh, it'll be an enum. Yep. And one of the types that can be is path. Is another one array? It is. Cool. So, so what I might do is match this. Let's not lose that. Match you. Should I change it to a match? Sure. Then I can do like proper error handling for other things, I guess. Do I want to? I don't know if I do. Match. Okay, we're going to match that, and then we're going to do this. Do that. Then we're also going to type match type array, which, sure. And if I'm just going to assume that it contains the right kind of thing, which I can do for now. Right, yeah. If I'm just going to assume this contains the right kind of thing, then I can just do, so we could change this just to be iterable rather than vec specifically. Because all I care is that it's iterable. Iterable. And so we can just do that same code here, I believe. Children push, child field, iterable. Yeah? Any errors? Yes, we have errors. Oh. Right. Oh, you have to write it like that if you've got a reference. Guess so. And I don't ever actually use the array, yeah, because I never actually check anything about it. That's fine. Okay, so the macro compiles. Now, what if I do? So where did I have one of those? They were in objects. So here. So then the question is, can I do this, derive AST node, and get rid of this? Nope. No method. Traverse found for reference. Option. Oh. It matters whether it's, oh gosh, yeah, okay. Well, the funny thing is, I could, since I know the length of the thing, I could just generate. That is interesting, actually. I kind of want it to be recursive. Like, what if it's an array of arrays, or if it's an array of vecs, etc. But it's not. Should I just... That is interesting. So wait, what did it look like? The thing that I got rid of? This. No. This. Right, it loops over and it does that. For row and rows, yeah, okay. Oh, I do kind of need it to be recursive, don't I? Technically, I would do that with vec as well, and option. Yeah. Yeah. Oh, that makes things quite complicated. That makes things very complicated. I should do the least complicated thing, right? Okay, so if I have array, then we have a... Yeah, that would be the type of the elements. Okay. Which will be a path. Okay, so I'm just gonna have to do, yeah, I'm gonna keep it simple for now. So match, so we are gonna do array, keep it simple. Keep it simple for now. We can make it more complicated later when I need it to be. So it was elem. How does, like, I've actually managed to avoid using boxes entirely. How do I actually get, like I said, dereference it? I mean, that's not the best example, is it? Yeah, I just dereference it. Okay, so match array elem dereferenced. Is that right? Yes, and then it'll be once again type path. Yes. Yep. Path. And then we're basically going to do this again, aren't we? But there's also the situation where well, it's either going to be a node. Okay, let's just assume. I mean, I could just leave that, right? That would work, I think. I mean, I'd have to do an exhaustive match, which I guess is going to do nothing. Can't move out of this. Wait, so how does it work if it's a box? Right. I like how I had the asterisk. It's like, you should try removing it. So I just kept doing that and then save. Remove. Save. Add it. We're in an endless loop. Okay, what's the way of dealing with this? Data moved here. Can I... Isn't there a way of saying, like, ref? Or is it this? Type array found that. Oh, sorry, I'm doing the wrong thing. I'm doing totally the wrong thing. This down here, ref. There we go. That's what I needed. If I remove that reference, what happens? Okay, it's fine. Alright. So then depending on what that has inside it, it should maybe work. So here, do we get errors anymore? We do. Oh, because that's there. Get rid of that. Mismatched types. Expected found option. Yes, because now I need to actually... Okay. I need to have another type of child field. Do I? I mean, I guess it should be an iterable. And an iterable has a... I can't do a recursive type. I could just do... Okay. Let's just assume that we either go to an iterable options or iterable nodes. Sure. So up here we're assuming iterable nodes. Down here, depending on... So we're not going to have that. Iterable options. Iterable nodes. Then down here, this is definitely not super tidy, but it's fine. So iterable options needs to have the if let some. Oh, hold on, no. Yes? Yeah, this will work, okay. But not that. Ident. I guess it's okay that I'm like gonna be shadowing the name. It should be fine, I think. No errors there. No errors there. Let's see if it works. It's definitely a bit nasty, but whatever. Oh yeah, I haven't run it yet after adding the AST node stuff, the macro. So it'll take a little while to build. Will it work though? That's the question. Thanks, CP Uniform. Appreciate it. Goodbye. Oh, it does take a while to build, doesn't it? I mean, why is it like compiling everything from scratch? Like, why is it compiling all this Bevy stuff? I'm not even using the Bevy stuff right now. I know I've still got it in my cargo file. Whatever. Just finish quickly, please, Bevy. Wonder why it is doing everything from scratch. Weird. Okay. Just warnings. Okay, seems compiled. Does it still print out sprites properly? It certainly does. Okay, cool. So that fixes that, and this one. I can put that here as well, I believe. Get rid of that. Amazing. So right now I can't do any of the ones that I get value, but okay, that's the thing. Let's commit that. Get add source. Allow our ASD knows to have array fields. Cool. There's still the question of whether they should, and whether I should actually have I should probably have a type. I mean, yeah, eventually I might just get rid of all of this and just make it so there's like an array node. I probably will do that at some point because I do eventually want to have like extra data associated with each node, but for now I don't need it, so this is the easiest way. Okay, so the next thing to do is enums, which are quite different. Where do we have an enum? Here's an enum. So legend item value node, we're going to try and get this to work. So it's going to have to be quite different because it's an enum instead, and the traverse just comes out entirely differently. So I want to be able to add that there and have it work. That means for each variant in the enum generating a thing like this, do I ever have anything that's like, so in this case they're both nodes. I guess I can just assume for now that they are, and then change it later if they're not. So this is definitely looking pretty ugly. So we're going to change this to a match. It's like so deeply nested. Match input data to this. I mean, should I change it to a match? It's almost clearer as an if let. Yeah, whatever. It's too late. Okay. So I'm assuming I should check. There's going to be a data enum. Oh, what should I call enum? Because it's a keyword. Enum. Enum underscore. I don't know. Maybe that. We're gonna need that. We are gonna need this though to do nothing. Well, maybe not to do nothing actually. Panic. ST node can only be applied to or should I do? I could do. Can Panic take? Can it format stuff, or do I have to format separately? I probably have to format separately. Is not a struct or an enum. Oh, that does work. Okay. Yep, unused indeed. Okay, so what can I get out of an enum? So no, not here. What do I want? I want data. Where's data? It's probably this. Data. Yeah, data enum. Cool. There's variants, which are punctuated, and punctuated is iterable, so I can do 4 variants. Yeah, easy. It's going to be very similar. For, oh gosh, not there. For variant in enum variants. What are we doing? For variant in enum variants. Hello, Marcos. How are you doing? I'm doing some fancy Rust stuff. It's quite ugly code right now, and it might stay ugly forever because I hopefully won't have to touch it very often. But I'm doing fun stuff. I'm making it so that I can just put. So that, I guess my best example currently is like here. This is pretty good. there used to be code like this between every single one of these. It wasn't exactly that, but it's very similar to that. And it's gone because I'm doing a macro derived from AST node, and it just generates the functionality for an AST node. And that functionality is like, it like loops over the fields of the struct that it's applying to, like the AST node, it loops over the fields and it generates a, depending on what it is, if it's a vector, it generates a loop over the vector. If it's a node directly, it just calls traverse on that node. So that's what these are, sorry. So here we go. If it's a vector or an iterable, it loops over the field and traverses each thing in the iterable. If it's an option, then it only traverses it if it's there. If it's if it's just a node directly, then we just traverse it directly. And now I'm trying to. So the thing I'm trying to do right now is make this macro work for enums as well. And I was using, which one was I using as an example? This one, legend item value node. This is an enum. Which can be one of two different nodes. It can be either a reference or it can be a conjunction. And so the traverse function that I generate from my macro, this is my manually written one, but I want the macro to automatically generate this. I want it to generate this function with these different match branches. So it's got to generate a match branch for each variant in the enum. And those look pretty much identical to each other. So as long as it does that for each one, we're all good. So this should be simple. So back here, for variants and enum variants. Okay, what does a variant contain? Variants. And what do I need to know? I need to know... do I just need its ident? I think so. Okay, so we're going to make a new thing, which is going to be, it's not children, it sort of is children. I was going to call it variants, although is that going to map? Yeah, we're okay. Variant children, I guess. And I guess we're just going to do variants. Variant children, sorry, dot push. Variants dot ident? Wait, is that the whole thing? Can't move. I have to make it a vector of references, which I can do just by doing this. Yep. Cool. So I'm pushing all of the variants into here, and then down here I want to expand variants. I could make this smarter because we're never going to have children and variant children, but whatever, this will do for now. Variant children. And what that needs to do is, no, we're not doing that. We are doing quote rust crate. Where's the stuff about looping? Repetition. So yeah, you can just write code in there. Okay, so I'm going to generate... well, okay. Ooh. 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 I want some code to be there only if we actually... Okay, maybe I should do the change I was thinking of making. So I think I want a new enum down here, which will be children, and it's either fields variance. In the case of variance, it's going to contain a vec of idents. In the case of, sorry, no, the other way around. That's going to be that. In the case of variance, I mean, it's always a vec of idents. Yeah, we're good. But I do need to know the difference between those two cases. I'm going to implement 2 tokens on that, am I? No, this, oh, I'm wrong here. If it's fields, it's a vec of child fields, yes. If it is, if it is variance, then I guess I want a new thing, do I? Not necessarily. That could be fine. And then I want to impl this, 2 tokens for children. Which is going to match self if we are a fields. We do one thing, if we're a variance, we do another thing. If we're a fields, we just do what we're doing up here, which is this. Fields. If we are a variance, then instead we want to generate the code that I had in Legend. This. So visit depth. Oh no, the visit depth's already there, but that's fine. I can just remove it. So we're going to generate a match where within the match we are going to expand over. Yeah, this will be fine. I can do self. Maybe I should do it like this. Self. Variant. Oh. No, that's fine. Yeah, okay. So you can do an array. That's fine. Yep. Variance. This is so weird. I think this is fine. Variance dot traverse visit depth plus 1. Maybe. This code's not going to be right though. So basically I want to expand children, where children is one of these, but I want that to depend on, so okay, so it's going to be let children equal, is it? Sure, it can be, yes, okay. Let children equal this match, and then we are going to return, will this work? Sure. We can do let mut children equals vec new. Well, we'll do fields. And then we'll say at the bottom of here, return. I guess I could do. I guess I could just do children. Children fields. Where this is going to be. Oh, it's an enum. Whoops. That's. So it will just be like this. And then at the bottom we'll return children. And then for the other one, we'll do children variance. Return children. Oh, we don't want return. Return's the wrong thing. We have to do this nasty syntax that I don't like. I'm getting semantic satiation from the word children. Is that okay? There's gonna be errors there. What are the errors? Okay, apparently I've just probably missed a. Yeah, maybe I should just do. Okay, I'll go back to what I was going to do. Fields. Children. Fields. Okay, that works. I'm missing a semicolon. Expected children fields. Okay. I'm surprised we don't get an error here for the same reason. Oh, because that is just directly a vector. Wait. Oh, no, I see. It's still using that up there. So this should give an error now. Yes. Can't find children in scope. Yeah, because I changed it to fields. Ugh. Okay. Variance. Children variance. Yeah, because that should just be vec new. Okay. Okay, what? Maybe it's just because of this. Right, you need an A. Okay. It's not because of that. Mismatched types. This error originates in the macro outside of the current crate. Expected has iterator. What he's saying, it's not from me. No, it can't be from here. I'm not even using it yet. Something about this. So children is that, which is going to be a children. And I have implemented 2 tokens, which will return different tokens depending on the thing. Yeah, it's grown on me to have the error messages appear in the editor. Because that's just the default if you like set up. Like for Sublime, there's a package called Rust Enhanced. Rust. I guess because I've already got it installed. Packages. List packages. Yeah, I've got Rust Enhanced installed. And it just by default comes with that. And at first I was a bit like, oh my gosh, that's terrifying. But it is kind of handy. Still, what's wrong with this? So children. Expected has iterator. Found there is no iterator in repetition. That to me implies that this. Oh yeah, of course. That is not. Yeah, that's all that is. Okay, is this gonna work? So the question is, can I add this and get rid of this? And have this compile? Huh. What? Oh, that's funny. Because I end up using in the macro, I like take this identifier and in my expansion of it, I end up using that identifier as a variable name, and I'm getting an error in my code over here about using a variable that doesn't have a snake case name. That's funny. Okay, how do I change the name? I mean, there is a way to do it. Is there like a, I'm wondering if there's like a convenience method. Rust quote create snake case. Paste. Ugh. What does paste do? The nightly blah blah blah. I mean, I could do it manually without installing a new library. Yeah, I'm a bit bothered by that, so I'm not going to do it. I'm going to do this, this. Oh, but I have to do it for each one? Oh, no. I suppose I could do it as a... I need to get some water, so be right back. Hello, hello. The plugin sees inside the macro. It's more that, like, effectively the macro is defining some code that effectively gets injected into the file, and so the the warning that I get from that code that's injected. I mean, it's not just injected because it's cleaner than that. It's not like C++ macros or whatever, or C macros. But it's kind of like it is, and the warning that I get from that injected code, it attaches to, it very cleverly attaches it to the right place, which is kind of, whoa. Even though like the derived macro's up here. Anyway, like I don't know what it'll even do. Right, I guess so. The warning's on there because it thinks like that is the source of the error. That's funny. So what I was going to do is I was going to see if I could. I guess one option is to make this actually a vec of a pair of things. Or I could generate the pair in here. I kind of wish this quote thing just had the ability to do this. Like I wish I could say like lowercase variance. Rust derive macro snake case. Oh, everybody's using this paste thing. I kind of... Okay, let's just do this. I can do this. I can add another one. Basically, when this is not the ideal way to do this, really, but... I mean, why don't I just... Yeah, okay, why don't I just... variance map variant, well, I've named everything badly here. Maybe we should do a cleanup afterwards. So we have an ident and I want to rename it, and I can do toString on an ident. So I can do like net name equals variant dot toString, I believe. I'm sure I did that above somewhere. Name toString. What's name? Name is the ident. Yep, okay. What was that? Here, toString. Then I can do like let I guess this lowercase name equals name. Is it to lowercase? Rust stir lowercase to lowercase. And then return both name and lowercase name. This isn't going to work. This still isn't going to work. Yeah, what's a good way of doing this? I feel like the quote, like this feels like it would be such a common thing that I'd expect the quote crate to say something about it. Constructing identifiers. Yes. Yeah, okay. Format ident solution to build a new identifier token with the correct value. Such a common case. Okay. What about like changing the case? So sure, okay, so that makes a new one. And how? And yeah, also, what about doing it in a loop? I can think of a way of doing it. It's just not ideal. Can I think of a way of doing it actually? Bad case of case, exactly. Like how do I kind of iterate over two things separately? Like iterate over a tuple and access different elements of a tuple. Rust quote repetition tuple. Not what I was looking for. Iterated twice. Field name, field type. Field name, field type. Yeah, wait, how does this work? So that's a loop. Yeah, how does that work? Wait, can you just have two iterables and it will sync them up? Or maybe not, because that's the question. Yes, okay, that's the question. What's the answer? Address can only be used 0 or one time, not multiple extended Rust and doesn't involve. Yeah, okay. But that's not what they're asking, is it? Maybe it is what they're asking. If you took the iteration by mutable reference, iterating through it once with exhausted, leaving no values for the second usage, you'll need to clone the iterator. You can collect the iterator into a vec. I feel like they've misunderstood. Although it got accepted. Maybe you can just do two separate. So if I just return lowercase name here, lowercase idents, lowercase variants. Can I do that? No. Both map access for that reference, but the straight bounds are not specified. You what? Oh, because that's a string. Oh, so I want to use that thing. What was it just saying? I want to use this thing. Format ident. Right? Oh. Sure, you don't exist, but you will do if I import you. Okay, but we still have an error here. The method map exists for reference, yes, but its trait bounds are not specified. It could be called on the just unspecified trait bounds. Doesn't specify iterator. Why does it not? Following trait bounds were not specified. Oh, do I? Okay. Right. So what does map on a vec? What does calling map directly do that's different to... Wait, is there no map? There is no map, okay. Then why? Oh, whatever. Maybe there is actually. No. Okay. Whatever, that felt like a confusing error message. But maybe it's because I'm doing macro stuff. Okay. So it seems like I can reference two separate iterables. Maybe it just like zips them together. Where's my file? Legend. Save. Oh, save. Ooh, it maybe works. Run. It seems to maybe work. Legend item value. Let's find the legend items. Legend item. Yeah, it's working. I think. Legend item value. What is the legend? Oh yeah, it's that thing. So yeah, here we have, okay, legend item value, identify, create, conjunction, and okay, works perfectly. Awesome. So now let's go through and add, that's different. That's not an AST node. Okay, every place we've got an enum AST node. Objects definitely has, apparently it does not. How is my object file so short now? Or do I like not have many enums at all? Okay, rules is huge. That's not too surprising, I guess. Not that enum, but this enum, yes. Get rid of this. So I'm replacing 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 lines. I could have just highlighted it, I think. No, it doesn't actually tell me anywhere. Maybe it does if I close the... Yeah, 17 lines. Replacing 17 lines with one line. Ta-da! It just worked. I saved it and no errors. And then I'm replacing another probably 17 lines with one line. Ta-da! Ignore those ones. Ignore those ones. You saw nothing. And then we're going to replace another 17 lines with one. Ta-da! And then we're going to replace another 20 lines with one. Oh. Then we're going to replace another 17 lines with one. Then that might be the last one. Yeah, I think that was the last one. Are there any in here? Enum. It wasn't the last one. Ooh. This one might not work because it has variants that don't actually contain anything. So yeah, and for those, it basically does. I mean, I could make it work for that though, right? So right now, this little error, if I did this and get rid of this, but I can make it work for this. There's gonna be an error. Yep. Yeah, okay. And it's like, well, can't do win conditions and levels because they don't have a value. So let's make it work for those. So when doing this, like, okay, so what's going to happen if I just add a catch-all that does nothing? What happens if they actually already catch all? Is it fine or does it complain? It's fine. Okay, so Kate, I have a catch-all even if you're already catching all. Got it. That's good. That's convenient. So then all I want to do is not push any variants that don't have thingies, values. So variants, fields, discriminant. What's what here? What's a field for a variant? Data stored within an enum variant or struct. Yes, okay. It can be named. Maybe it's always unnamed. Named fields of a struct or struct variant. Okay. Struct variant. What's a struct variant? Let's just look at this. Okay, I guess it's that. I see. So you can have a... Oh, okay. And that's named? Unnamed fields of a tuple struct. A unit or struct or unit variant such as none. That's what I want. I want only... So if let unit, does it contain anything? No. If let unit equals variant dot fields, then we add it to the thing. Wait, no, if the opposite. Yes, the opposite. I mean, I could just swap this around or change this to a match. Let's change to a match. unit is going to do this. Otherwise, we're going to do nothing. Oh. Fields unit. Import fields. Okay, no errors. Where was that? I've lost track of it. Here. Okay, does that fix... Where was it? I no longer remember. It was an AST. Here. Save. Nope. So I should only be pushing variant if it's fields. Variant. What is the discriminant? Enum discriminant. Each enum instance is a discriminant, an integer logically associated to it that is used to... Okay, so that's okay. Understood. So it's definitely fields. Unit struct or unit variant, such as none. Unnamed fields of a tuple struct or tuple variant. Named fields of a struct. Unnamed fields of a tuple struct or simple or tuple variant. Unit struct or unit variant. That is what I've got, right? A unit variant. Oh, I want the opposite. I specifically want the opposite. Ah, that's the issue. Okay. Where was it? AST. Save. It seems to work. I'll go run. It seems to work. Seems to do exactly the right stuff. Cool. Let's commit. There's some ugly code, but whatever. Allow stnode macro to apply to enums. Cool. So the other case that I have is... What's the other case that I have? It is... well, so I have basically any node that is a leaf has a get value. And its traverse should do nothing, which is actually what would happen. Okay, so maybe like I can probably just apply. Now the problem is I can't. Okay, the problem is I can't apply this and also do this. Because it's like there are two implementations of AST node for this. Yes, because one of them is coming from the macro and one is coming from here. So that to me suggests that I need a separate trait. Like a valued AST node. The ones that are more important than the others because they're more valued. Oh. Wait, do I need that? I mean, is get value always this? Does the macro know the semantic of what you want in each case when evaluating the nodes? Does the macro know the semantics of what you want in each case when evaluating the nodes? So the macro. So let me find a simple example that's not too simple, that's also not too complicated. Here you go. Here's a perfect little example of an AST node, because so this is an object node. It's a node in my AST, and every field within this node is a child node within the tree. Like the object's name, the object's synonyms, the object's color palette, and the object's sprite, which is itself a node, and that contains the pixels and all that stuff, like all the rows of pixels, etc. By applying this derived macro to this, what it's effectively doing is looping through the properties of object nodes to generate, it's effectively generating impl AST node. I'm going to write it simply. Impl AST node for object nodes. Like, this isn't valid because I have to put a bunch of other things in it. It's going to generate a function called traverse, which takes a bunch of things. Well, it takes self and a bunch of things. And what that's going to do is call, well, okay, so one of the things that traverse receives is a function called visit. And the whole point of traverse is to call visit on every node within the tree, like going down to all the children and to their children and so on. So it's going to call visit on itself. Then, basically for each of these, it's going to do the appropriate thing. So for name, it would do self.name.traverse, and it would pass visit further down. And then for synonyms, because synonym is an option, we have to do if let some synonym, which is basically saying if there is actually a synonym, like if the synonyms are there, if they're not none, then synonyms dot traverse dot visit, etc. And so my macro is looping through, checking the type of each field and generating the code for each one. It's like not super clear to see how it's doing that. There's this bit at the top, which is this hugely nested thing, which is kind of disgusting, but it is what it is. Which is going, okay, so if the macro is on a struct, then we loop through all of the struct's fields. You can ignore this bit. If its type is an option, basically this thing is just looping through the fields, checking if they are something we can traverse down, and then adding those things to a list of children. It's like children to traverse or whatever, right? For the node that we're applying the macro to. And then with that information, here is where we actually generate the impl. So you can see it's like literally written out here. Like the thing I was writing before, I mean, I didn't put that in, but impl AST node for, and it's hash name instead of the thing, because hash name is the name of the thing we're applying the macro to. And then sorry, that's the the traverse function. Oh yeah, it doesn't put pub in because you don't need to put pub. But yeah, there's the traverse function it's generating, which the first thing it does is call visit on self. And then there's a bit of magic here where it's going, okay, I need to inject children, and children is this thing. It's an enum. This is quite complicated for us, but what it'll do is it'll go, well, like if let's say this bit didn't exist, and I just had an enum called children, and I was like, okay, I want to inject children here. Well, that's a terrible phrase. I want to inject children into my code. Well, it would complain. It'd be like, I don't know how to inject this. I don't know what you want me to inject. What code do you want me to generate for this thing? It's just an enum. What do I do with that? So to say what you want to do with that, you impl a thing called toTokens. So when you say impl, this might not be clear. I don't know how much Rust you've done, Marcos, but like this is like implementing an interface, sort of. It's implementing a trait, but it's like implementing an interface for a type. And so because I want this thing to be like tokenizable, basically, like turned into code, I have to implement toTokens for that thing. And then that function goes, okay, so depending on which kind of children we have, if we have fields or variants, we want to generate different code. And it, yeah. And it keeps going. Easy. Have I left this in an okay state right now or not? I think so. Oh. No. I changed stuff. There we go, I changed that. Let's hold on. What did I change? I've added derive st node to something that can't accept it. Yes, so there's an error currently in sounds. There should be, at least, if I save. Somewhere. No? Why is there no error? Oh, because I had undone it. Okay, yeah, now we've got no changes. Okay. To be clear, I did not advocate for injecting children. Wait, no, I do. I do in certain circumstances. If it's medically approved, please do. To be clear, I'm not an anti-vaxxer. I just want to get that out there, okay? Alright, enough about injecting children, and apologies to whoever just joined the stream and is like, wait, what are they talking about? So I guess that works. All good. So yeah, there's the question of how do we deal with this and get value. So I guess the thing I was just thinking is, can I generate this? Because I could find out if the type has a span field. And if it does, like, is get value always this? I think it might always be this. Should we just find them all? So wait, that was collision layers. Yep, they all look very similar to me. They all look very similar to me. That looks similar. Oh, I could totally generate this. I think there might be one where it isn't. No, they might all be that. Okay. That's just the default implementation. Okay, that sounds like I could very easily just say basically if so in the case of it being a struct, if the struct contains a field called span, generate a function that returns span's value. Like, what would be nicer is if I could like, I think what a smart library would do is like I'd be able to say like this is the value or something like this. Which I could do, but since I know they're all exactly the same, why don't I just do the thing that I'm trying to do? Now the question is, how do I like conditionally... Actually, no, it should be easy, right? I can... So here, I want to kind of conditionally implement a function. Sort of. sort of. Let's have a look. Syntax. I mean, I can think of a way to do it that would be pretty simple. Yeah. Like I can easily just say, I can have another thing which is like, ooh, can I? Can you just do conditionals? How do you do like condition? Oh, great. But yeah, I could have a thing, don't know what it's called yet, that is a type that implements, which again is an enum that implements 2 tokens depending on its value. Sorry, which variant it currently is, will output the thing. Okay, that sounds like it would work. What do we call it? It doesn't need a lifetime. Also, it doesn't need any of this. Node type, parent or leaf. Okay. So what we can do is just sort of, the simple thing is to let mute node type equals node type parent, assume parent, but if we encounter a field called span, okay, if field.ident equals span, then node type equals node type leaf. In fact, if it's a leaf that has no children, let's do this for now. Yeah, okay, but I can see a way to improve this. Right. Fields can be unnamed. If let's some field ident if field ident equals span. Okay. Node type. Yep. Okay, so implement 2 tokens for node type. Don't need the lifetime. Oops. Yeah. We have parent. So in the case of parent, we're going to return nothing. So I guess we can just do that. For leaf, we're going to return a function, the function. Where am I doing it? Which one am I testing with? I guess I could test with this one. So this function. What am I doing? Here, yes, okay. Any errors? No errors. Oh no, there's an error up here. Yep. Okay. No errors. No errors. Can I now do this? No way. I think it works. I think it works. I mean, I should run it to see if it actually does. So the key thing would be that I can still see the value of a layer member, okay? Let's look for that. Once this builds, okay. Well, collision layers, where are they? Where are they? Wait, is this collision layers? No, it's objects. Objects. Legends. Collision layers. I can still see the value of a layer member. It works. So now can I just apply that? Oh my gosh, this is madness. So, okay, so this is the next thing that I knew I was going to hit up against. I think list node I'm going to have to manually implement, it's fine. So keyword node, the problem is it has an extra field. Now the thing is, I do have an attribute I can add called skip, which would work for now. But if it's a child node, then I should know that I don't need to traverse any of its children. Whatever, we'll do this for now. It'll be better than nothing. So, does that work? No. Maybe some generic arguments. What? Right. That was another thing to sort out. Okay, so let's not do that one yet. Wait, where am I? Ah. Oh my gosh. Okay. This one I could do. This one I can do. Oh, I cannot apparently. Oh yeah, because I haven't got rid of that. And this one I can do. All this code I'm deleting. It's beautiful. It's beautiful. This one I can do. This one I can't do because it's got the extra thing. Although I can if I do skip. Which is better than that many lines of code. Yep, that works. Yeah, here I can just do it. Oh, why did I even include that? That's weird. Oh my god, look how short that file is now. How long was that file earlier today? Let's do. How do you get diff a specific file? Okay, against a particular commit. Okay. Okay. So earlier today. So this that commit. Get diff source puzzle script parser st objects. So all the red was removed. So remove that, and replaced with those 4 lines. That's not bad. Oh, That's not a thing. Derive AST nodes. So I can do it there, yes. Already done those. Ignore all those warnings. Nothing to see. I can't. Oh, I can do that one if I skip that. Can do this one. Nothing to skip. Is that all of them? That might be all of them. Okay. Let's have a look at that file as well. So between now and then, rules. Whoa, that's quite a lot of code removed. Okay, what did I just do? What did I just implement? Okay. Allow st node macro to apply to leaf nodes. I mean, I didn't actually run it. I should check it still works. Looks pretty good to me. Hooray. All right, that's probably enough today. Like something I also did since last time I streamed was I added a new helper function called parseLine, which basically handles the like, oh, I'm expecting to be at the end of a line, but I'm not at the end of a line stuff, which I was repeating in a lot of places. So now if I go to, for example, no, sorry, not there. If I go to here, you can see that prelude option does parseLine, and and you have to give it a name because when it does the error, it says unexpected text after that, and then but you also pass it a callback that or a function that does the parsing you want to do on that line. But if this returns, no matter what this returns, well, if this doesn't return, if it returns a node, and then there is stuff after that node on the line, it will throw an error. I think there's one where it's really neat. So yeah, here, I thought the way this came out was really nice. So for parsing a sound definition, so that's like a line. So, okay, a sound definition is, for example, like end level. Oh, okay, that's not a valid one. I don't think I have any valid sound definitions in this list. I can get up the game, I guess. There you go. There's a sound definition, or like end level. End level. That's. Oh, there's a thing there. I've got the rule showing an empty message every time I push, so we should get the end level sound. Yeah, we do. Anyway, so that's a valid thing. There's also like, you can do like crate. Can you do like crate up? No. What can you do? Crate, create. Can you do? No, you can do crate move up. And then only make a sound when moving up. Is that a thing? Let's remove the message so that I'm not being annoyed by it. Yeah. Don't know if anybody ever uses that, but that's a feature. Anyway, so there's the sound definitions. So if I go to sounds, so parsing a sound definition is parsing a line And on that line, I'm expecting one of these three things. And the three things are, like, that's one kind, that's a named sound, that is a trigger sound, that's an object trigger sound. That's the three things. And that's just like kind of neat. Obviously, once you actually get down into the weeds of what they do, it gets a bit more complicated, but still, I think that's like, that's a very neat bit of code. I think that is everything for today, though. I got my AST node thing working really nicely. So what was left with the AST node stuff? There was the fact that I'd like to avoid skipping. Maybe I should leave a to-do in here. There's a bunch of things I'd like to do in here, to be honest. Okay, to-do. We shouldn't even bother collecting children. We shouldn't even bother collecting children for nodes that are for leaf nodes. Then we can remove skip from leaf nodes. There's definitely messy stuff here. That's alright. Was there anything else I wanted to sort out? Why are you not changed? Okay, that was the other thing. To do. Cannot use AST node on a type that takes generic params. I mean, is the fix for that easy? Is the fix for that easy? Like, basically, this has to be able to take arbitrary things. Rust quote creates generic params. Oh my gosh, what's going on here? I don't think that's what I want. Maybe. Do I have to do it like that? Surely not. There's got to be a nice way of doing this. Where was the example? Here. Keyword node. No, there's got to be a nice way of dealing with this. Can you not, like... I'm gonna sneeze, I think. Yep. Oh, I'm gonna sneeze again. Is that the last one? Maybe. Okay, so... The thing is, you can't, like, leave these off. I'm gonna sneeze again. Oh no. Should have taken a hay fever tablet today. Big mistake. I'm definitely going to keep sneezing. Oh dear. Can I say Rust impl where impl doesn't care about generic params? Rust derived macro any generic params. You completely ignore the checks which you simply can't do. You could simply forward them. That's what I want. I want to forward them. Yes, please. Maybe I do this afterwards though. Actually, this might be simple. Okay. Split for impl. Oh, okay. Yeah. They've made this really simple. It's not AST, it's called input for me? Or is it called AST? No, yeah, it's called input. Input, generic, split for impl. Okay, and then you do this. Impl generics. Oh, cool. So you do that. And then type generics with where clause. Whoa. Does that run? Oh, so what does it compile? It does compile that. Then can I do this? And get rid of this? No. Oh yeah, no, that's fine. That's because I need to skip this. Oh, that's so cool. That works. Okay. Allow macro to apply. Oh, wait, that's not the word I said. Allow AST node macro to apply to types with generic params. Sure. There we go. Okay, I'm done for today. That was a good day. I did a thing that I'd been putting off for a while. A thing that simplified my code massively, which is neat. Alrighty, thanks for joining, folks. Anybody that sees the chat is going to really wonder where the conversation went. Don't worry, it all stemmed from this line of code where we are injecting children. That's the explanation. Alright, goodbye folks. I'll probably do some more programming tomorrow, maybe. And I'm probably gonna play loads more Animal Well as well, because it's really cool. I'm a lot further than my videos. Well, not a lot further, but a bit further. Anyway, alright, goodbye.